Now that the different subatomic particles were discovered, electrons, protons were discovered, the question arises as to how these are arranged in an atom, how these subatomic particles are placed in an atom. So several scientists came forward and proposed their model of atom. Out of these, the very famous and the most accepted one was Thompson model. J. Thompson in the year 1898 proposed his model of atom, in which he said that atom is a sphere of positive charge in which the electrons are embedded or distributed like this. So he compared this model with that of plum pudding. Okay, pudding, you know, it will have liquid mixture in which the fruit pieces are mixed. Yes, so the liquid mixture of the pudding is the positive sphere, and the pieces of the fruit, these are like the electrons. Okay, and also this model was compared to that of watermelon. If you take the watermelon fruit and cut it in two pieces, you'll see that the reddish portion, okay, the reddish sphere, the circular portion is the positive sphere, and the seeds of the watermelon would be the electrons. But later this model of atom was discarded because it could not explain the result of alpha particle scattering experiment done by Rutherford. So next comes the Rutherford model. Rutherford carried out his experiment called alpha particle scattering experiment. This you have done in the lower classes as well. So for this experiment, he took a very thin gold foil of about 0.004 centimeter. It's very thin sheet of gold, and outside he placed a circular screen coated with zinc sulfide. So when a charged particle, it hits the screen, it will cause an illumination. And he bombarded this gold foil with alpha particles. Alpha particles, you know, these are the helium ions, He2 plus ions, which has got 2 protons and 2 neutrons. It's quite heavy, okay, heavy charged, positively charged particle, alpha particle. So when he bombarded the gold foil with alpha particles, he observed certain things. First, he observed that nearly 99.9% of the alpha particles, most of the alpha particles, passed straight through the foil undeviated and produced an illumination out here. The next, he saw that very few alpha particles underwent a slight deviation, was deflected by a small angle. Okay, deflected means changed their direction by a small angle and caused illumination out here, or got deflected and caused illumination out here. And still very few, that is 1 in 20,000, very less alpha particles suffer deflection by a very large angle, like for example got deflected here and produced an illumination out here, got deflected out here and produced an illumination. And very few alpha particle got deflected by 180-degree angle and caused an illumination on the zinc sulfide screen placed out here. So let's see out here. This is the gold foil, and these are the alpha rays, alpha particles. Most of them are going undeflected. Out here, this alpha particle is deflected by a small angle, and here it is deflected by 180-degree. This is 180-degree deflection. So based on this observation, he concluded that since most of the alpha particles were going undeflected, it means that most of the space in an atom is empty, is vacant. And very few alpha particles, they were getting deflected. Okay, so there must be some positively charged particles, and also this positively charged particles must be big, because alpha particles, you know that they are big particles. So in order to deflect these big particles, the positively charged particles in the gold foil should also be big. And also he saw that the number of alpha particles which got deflected was very less. So he concluded that the positive particles were present in a very small space in an atom. All the positively charged particles were concentrated in a very small space in an atom. That is why only very few alpha particles got deflected. So alpha particles, these are positively charged. Yes, it will be deflected by another positively charged particle. So when it passed near the positively charged particle concentrated at the center, it got deflected. When it hit head on, it got deflected by 180 degrees. So based on these conclusions and observation, he put forward his model, okay, which is called here Rutherford model, in which he said that an atom consists of two parts, nucleus and the extranuclear part. Nucleus is the central part of the atom in which all the positively charged particles, that is the protons, were concentrated. And the size of the nucleus was very, very small compared to that of size of the atom. Have a look. If the size of the nucleus is 10 to the power minus 12 or 13 centimeter, the atom is 10 to the power minus 8 centimeter. It is almost 10 to the power 5 times smaller than the size of the atom. It can be compared like this. If you consider the nucleus to be a cricket ball, okay, then the atom would be the ground, okay, the playground, where the radius is about 5 kilometer, okay, 5 kilometer radius. Just imagine it's very big, yes. And the size of the ball, imagine the size of the cricket ball, that's your nucleus, okay. So it's 10 to the power 5 times smaller than the size of the atom. And the other one, the extranuclear part, is the part outside the nucleus in which there will be electrons which will be moving in circular orbits. And since the atom is electrically neutral as a whole, he said that number of electrons should be equal to the number of protons. So if this is the nucleus, okay, positively charged, the electrons will be revolving around the nucleus in circular orbits. And this can be compared to the solar system. Sun is at the center and the planets are moving around the sun in orbits, circular orbits. And he explained the stability of this model of atom, or the stability of the electrons, like this. So electrons are negatively charged, the protons are positively charged, so there will be an electrostatic force of attraction. Okay, you know that attraction between the oppositely charged particles, it is called electrostatic force of attraction. Electrostatic force of attraction. And this will be balanced by, since the electrons are moving in circular orbits, there will be a force acting outwards. Okay, you'll learn in physics. It is called centrifugal force. Centrifugal force. Okay, so the force acting outwards and one force is acting inward. So these two forces are balanced. So if you take Fe, that is the electrostatic force of attraction, would be equal to the centrifugal force. So they revolve around the nucleus in circular. So these two forces are balanced. So this is how he explained the stability of the atom. Even Rutherford's model had some drawbacks. Drawbacks or the disadvantages. Like it could not explain the stability of atomic structure. You know very well that Rutherford had explained the stability of the atom like this. The force of electrostatic force of attraction would be equal to that of centrifugal force. That is why electrons revolve around the nucleus in circular orbits and they are stable. But around that time, a scientist called Maxwell stated a theory which was this: a charged accelerated particle emits radiation and loses energy continuously. He was doing his research in electromagnetism and electricity. Okay, and if you apply this theory to electron, you know that electron is a charged particle. It's a charged particle and it is accelerated. How accelerated? Because it will be moving in circular orbit. That is why it will be accelerated. Acceleration means what? Change in velocity. There will be a change in velocity at every point. Why? Because there will be a change in direction. Yes, so electron is a accelerated charged particle. So it should emit radiation and lose energy continuously. So if this happens, then the electron will lose energy continuously, and if it loses energy continuously, it will be forced to describe a circle of smaller and smaller radius. Yes, like this. It will go in spiral mode. Yes, and finally fall into the nucleus. Yes, but this does not happen. So Rutherford model could not explain the stability of the atomic structure. Another drawback was that he did not say anything about the distribution of electrons in the extranuclear part. Okay, he said that electrons revolve around the nucleus in circular orbits, but he did not give us any idea as to how they are arranged or they are distributed. And also he did not say anything about the energies of these electrons. So those were the drawbacks. Now after that, let's see a little bit. You know about atomic number and mass number, but still let's revise a little bit. Atomic number represented by the letter Z, and it is the number of protons. Okay, so in a neutral atom, the number of protons is equal to the number of electrons. Mass number represented by A, and it is the total number of protons and neutrons. Okay, protons and neutrons together, they are called nucleons, represented by the letter A. So if you have to represent an atom, okay, X, you write the atomic number below here, subscript, and the superscript is your mass number. Like for example, carbon, this is atomic number, this is its mass number. And there are certain terms here, isotopes, you know that, atoms of the same element with the same atomic number but different mass number. Like for example, these are the isotopes of hydrogen. Yes, the atomic number, as you can see, they are same, but the mass number are different. The reason is because of the different number of neutrons present in them. This is called protium, deuterium, this is called tritium. And chlorine also has two isotopes, isotope 35 and 37. Isobars, these are the atoms which will have same mass number but different atomic number. So potassium and this is argon. Have a look. The atomic numbers are different elements, but their mass number are same. And isotones, they will have the same number of neutrons. Like for example, nitrogen 15, okay, and oxygen 16. Have a look. If you calculate the number of neutrons, you'll find out it is 8. I hope you know how to find out the number of neutrons. Okay, how do you do? A minus Z. So 15 minus 7 out here, 16 minus 8 is your 8.